Hi, my name is Emily Dahlberg. The engineering design process, also known as the EDP, is a powerful strategy that brings together the essential components of STEM: science, technology, engineering, and math. Our PLC has been discussing the benefits of the EDP and how it can be successfully implemented in the classroom. Too often, in K through 12 classrooms, these subjects are taught in isolation, but the EDP provides meaningful opportunities for students to connect concepts across disciplines and apply them to real-world problems. Take, for example, a cross-disciplinary project where students plan and design a capsule to protect an egg as it is dropped from a considerable height. To do this, they must use their understanding of math, engineering design and construction, and various physics principles. This kind of project moves students beyond rote memorization and instead invites them to participate in the real work of STEM, analyzing and solving problems, considering multiple ideas, and learning through testing subsequent iterations of a solution.
Our PLC can help with implementation for teachers in their classroom in a variety of ways. PLCs are collaborative groups of educators who meet regularly to share ideas, analyze student work, and continuously improve instruction. Within our STEM-focused PLC, we can assist teachers by helping them align engineering standards to their curriculum, helping co-develop lessons and projects to use with the engineering design process. We can also share ideas for interdisciplinary topics that integrate math, science, technology, engineering. We can share challenges with implementation and help troubleshoot those challenges collaboratively, and also help find solutions or alternatives. And we can also help support in refining lesson plans based on classroom experiences. Implementation goes much smoother when we work collaboratively, troubleshoot together, and share ideas for success.
Hello, I'm Dolores. Another vital function of a PLC is assessing how effectively students are using the engineered design process. The PLC can help create common, formative assessments that measure not just content knowledge, but also how students approach problems, iterate on designs, and collaborate. We can also use student work, data, and reflection journals to identify common challenges and adjust instruction accordingly. For example, maybe the reflection journals show that students found the revision phase the most challenging. We can take this information and collaborate on how best to support the students in this phase. That's the kind of insight that drives meaningful instruction change. PLC time also allows for peer feedback, lesson reflection, and unit revisions, all centered around what's working best for our students.
Hello, I'm Robin Boley-Bowie. In my future professional practice, I plan to implement the engineering design process through rich, hands-on projects, like the egg drop project we discussed. I will have students identify what they believe to be a real-world problem or challenge related to the state standards being taught. In small groups, I plan to have them brainstorm solutions using mathematical reasoning and other skills they are learning in their other classes, like science and technology. My students will discuss with me and their group which ideas may work out to be the best plan for a solution before they design their project. Each group will build a working prototype to test, and they will improve their prototype based on initial testing before presenting to the class. I will use graphic organizers, color-coded visual aids, and sentence frames, among other supports, to differentiate for my English language learners and students with learning disabilities. To keep my gifted and talented students engaged in learning at a deeper level, I plan to add variables to projects and have them derive their own formulas to solve real-world problems.